Okay, let's continue with the solution. One of these days I will finish this. I feel like I've been doing this for as long as I remember, but anyway, I don't even know what I'm talking about. Question 1. Let's focus on the task at hand. Okay, the key I think is not to be intimidated by complicated diagrams such as this. So if you look at this, and I think in the exam they tend to give you something like this, maybe a little bit less complicated, but the key is not to freak out when you look at it. Whatever graph they give you, whatever diagram, it's going to be of something that you can solve. So deep breath, read the information, and try to think about what they're trying to tell you. Okay. The rise of personal portable devices has significantly expanded the lithium industry in the past 50 years, blah, blah, blah. Below is a schematic diagram for the production of lithium metal. So one of the things that you want to really think about, and I forgot that it does that. I'm going to have to go back to this question. One of the first things that you need to consider when you read this is you need to identify very quickly what topic this is on. And this is a SAC, so it's not hard to tell that this is on electrolysis. But if you have an exam, then you can see right here that the question is about electrolysis. And the purpose of this process, now this is production of material. The purpose of this process is to produce lithium metal. So later on, when they ask about what will happen if we do this and if we do that, how is it going to affect the operation of the cell, try to always link back to the purpose. The purpose of the cell is to make lithium. So how would the change affect the production of lithium? And probably the most important piece of information here is that we're using molten lithium chloride. It's a very good idea. Now, I think I'm not at a very good angle with the pen here. You need to be able, okay, that's not any better. You need to be able to translate this information into formulas. Molten lithium chloride means I have Li plus liquid and Cl minus liquid, and I do not have any water. So a lot of crucial information happen here. You know that the purpose of the cell is to produce lithium metal. You know the process is electrolysis, and you know that you need molten lithium chloride. So I don't even really need to look at the diagram at this stage. Anyway, the diagram is designed to confuse you and scare you. So try to remember that, and try to take a deep breath and just try to read it as carefully as you can. So if we just quickly look at this, now to be honest, every electrolytic process looks slightly different, but you still can identify the common features. I mean, the whole steel casing and ceramic lining are really non-consequential. But there is a cathode, and the cathode is this bit. Let's see whether I can change to another color. Okay, the cathode is here. That's not any better. This is the cathode. That's terrible, actually. This is the cathode. Also, is it gonna do that thing when it? Yep. Also, the outside. So the outside is the cathode. The anode is the inside. The anode is D. So this is the anode. And the reason why I gave the cross-section area is because I want you guys to be able to see that the diaphragm, which according to the question allow only ions to go through, this diaphragm actually surround the anode and separate the anode from the cathode. I want you guys to see that because I thought that if you look at this you couldn't really tell, so that's why it includes cross-section area. Everything else are just extra details that you didn't need. Anyway, part A, write a half equation for the reaction at the anode. I already include the answer here, and honestly, if you identify these two species as the only two species present, it shouldn't be too difficult to work out which one is going to be the reaction at the anode. You do, however, need to remember that the anode is the sign of oxidation. So you need to give me an oxidation equation here. Now, when in doubt, check the electrochemical series. So if we look at the electrochemical series, we can see that we have chloride ions here. If I'm just going to quickly highlight that. And now here we have lithium ions. So all you really need to do is to write the half equation in this direction. Will go from 2Cl minus 2Cl2 plus 2 electrons, and you need to change the state to liquid because the cell is molten. And that's all you ever need to do. I don't know why I did that. That's all you needed to do to get a mark. And I think the main problem here is people just made so many mistakes with balancing equations, and I don't even know what I'm doing there. So take the time and check that, because you really cannot afford to lose marks on questions as simple as this. Moving on to part B. Now this is where things start to go really wrong. During operation, the metallic lithium produced floats on the surface of the molten salt and is collected into a holding tank. The tank is not shown in the diagram. Argon gas is continuously pumped into the tank. So argon gas is not pumped into the cell, it's pumped into a tank that is used to collect lithium, which means that at this point, lithium has already exited the cell. So a lot of people, when they wrote the answer to this question, started talking about how argon gas is to prevent lithium from getting into contact with chlorine, but lithium already exit the tank, so you can't really say that. If you see a gas, especially an inert gas being pumped, and okay, pump is probably a better word here, into anything, what you really should think of is that it is there to replace oxygen gas. And I think I did accept a few other answers, but ultimately the argon gas is there to replace oxygen gas, which is the most reactive gas in the air. And if that is what you suspect, then you can check with the electrochemical series. And we're just gonna stop highlighting this. Oxygen is here and lithium is now, lithium ions, sorry, not lithium ion, lithium is down here. So if I just look at, probably not the correct oxygen there. Yeah, can I, all right. If we look at oxygen, this is oxygen and this is lithium. So there is a spontaneous reaction, quite a violent spontaneous reaction actually, between lithium metal and oxygen gas. So the reason why we need to pump the argon gas, which is inert, into the tank is to prevent this reaction from happening. Now I did accept answers to which say things such as lithium is a very, very reactive reducing agent. But if you want to be sure to get the mark in the exam, you want to mention oxygen gas there. And the fact that they can spontaneously react with each other. Now, I tend to refer back to the purpose of the cell. If you want to produce lithium ions and, sorry, if you want to produce lithium metal, and you really need to make sure that lithium ions are not accidentally remade, because if you go through all of that trouble just for lithium to react with something else and turn to lithium ions again, then all of that hard work, has gone to waste. That's not what we want things to. Okay, I'll stop talking now. I have no idea where I'm going with that. Anyway, so mention oxygen is a good idea. Part C, explain the function of the diaphragm. Include an equation to add your answer. Now, this is a 2-marker. And I think, well, some people missed the equation. Some people wrote an equation that's not balanced or something like that. And yes, you can say that the diaphragm allows, and it does allow ions to go through. And some people mentioned that it will allow ions to go through to balance the circuit. Now, considering how lithium chloride is here, it kind of looked like the electrolyte has access to both electrodes, regardless of whether the diaphragm is there or not. If you really want to talk about electron flow, you actually, well, I reckon you can say that it's going to go in. So the positively charged Ion's going to go towards the cathode, the negatively charged ion's going to go towards the anode. But at the same time, that is not that necessary, considering how the anode and cathode are both submerged in the electrolyte, so they will have access to the electrolyte no matter what. The main reason why we need the diaphragm is because you need to separate the products of electrolysis. And this is a very, very important point for any industrial process that uses electrolysis to produce materials, because the product of electrolysis can react spontaneously with each other. If you don't separate them, they're going to be reformed into reactants, and that just defeats the purpose. So you are not going to get the mark, the explanation mark anyway, unless you have in your answer that the diaphragm will prevent the product of electrolysis from coming into contact and with each other. You have to say that to get the first mark. So you have to focus on the main purpose of the diaphragm, which is to separate the products of electrolysis. And to expand that answer, you need to show me this equation, which is the spontaneous reaction between chlorine gas and lithium metal. So 1 mark for this, 1 mark for that. And unfortunately, I am not going to accept any other equation, mainly because this equation will happen if the diaphragm is not there. But if you write the half equation at the electrodes or the overall equation of the cell, that can still happen. That's not why the diaphragm is there. So you need to show the equation that the diaphragm is trying to prevent from happening to get the mark. Try to I think it's a very hard thing to do, but you get better with practice. Try to guess the intention of the question and think about what will distinguish you from other students. If you can write the half of the equation of the spontaneous reaction, that is better, because in the previous part, I already asked for the half equation. There would be a little bit unreasonable to think that I will ask that again for this question. The answer must be something else. So try to be smart about things like that. It's very rare that we ask the same thing twice in a question. So it must be something else. Okay, moving on to part D. I don't even know why I say okay, like no one's here. Suggest why the carbon anode cannot be replaced with an iron electrode. Okay, this is a 2-mark question. When we talk about replacement of a part of the cell, always go back to the electrochemical series to think and consider whether that is going to compete with anything. Now, I'm just going to highlight things again. So chloride is here and iron is down here. So I think a lot of people get the first mark for pointing out the fact that iron is a stronger reducing agent than chloride ion. So if you use iron as the anode, it is going to be oxidized into Fe2 plus ions. So that's the first mark for saying that Fe is a stronger reducing agent than chloride ions and would be oxidized preferentially at the anode, producing Fe2 plus ions. Now the second mark is for thinking about what would happen after that. So if Fe2 plus is produced, and I don't think, yeah, I'm not entirely sure how to do that, so I'm just going to use this. If Fe2 plus is produced, Fe2 plus in turn is a stronger oxidizing agent than lithium plus. So it is going to be reacting preferentially at the cathode, and ultimately that means that you cannot produce lithium, which is the purpose of the cell. So a very good answer for the second mark is to say that iron 2 plus can migrate to the cathode, where it will be reduced into iron. Therefore, lithium cannot be produced. You really always want to link back to the purpose of the cell and how any of the change may make it more difficult for the cell to fulfill that purpose, which is ultimately what you use the cell for. Okay, part E. Similar to lithium, sodium metal can also be produced via electrolysis of a molten electrolyte. During this process, calcium chloride is usually added to the molten sodium chloride to lower its melting temperature. It has been proposed that calcium chloride can be added added to lower the melting temperature of lithium chloride as well. So ultimately what the question is asking, is it proposal feasible? Is it possible to add calcium chloride into lithium chloride? So can you lower the melting point of the electrolyte of this cell with the addition of calcium chloride? Now, once again, you are introducing a new species into the electrolytic process. So you really want to go back to the electrochemical series to consider whether that is going to compete with anything. Now, in order to do that effectively, you do need to convert calcium chloride into Ca2 plus and Cl minus. Okay, now Cl minus is still Cl minus. Cl minus already present, so it's not going to do anything. If any competition is going to happen, it has to be of the calcium ions. And yes, calcium ion is a stronger oxidizing agent than lithium ions, and if you have calcium ions present, it would produce calcium at the cathode instead of lithium, and that is going to interfere with the cell. So that this proposal is not feasible because calcium ion is a stronger oxidizing agent than lithium ions. So I think the moral of this question is that every time a new species is introduced into the cell, and there are quite a few things here, well, at least two questions, one after the other, that it asks you to predict what would happen if you do this. What would happen if you introduce iron into the cell? What would happen if you introduce calcium ions into the cell? You need to check the electrochemical series to see whether any new competition is created by that introduction, and make sure to use the correct formula in your answer. Clearly distinguish between oxidizing agent and reducing agent, and if it is an ion you're talking about, write the formula calcium 2 plus ions. You don't want to get mixed up between calcium ions and calcium because they are completely different things. Honestly, I thought this question could have been done a little bit better, but I think there were a lot of mistakes on this page. So it's a very good idea to try to redo this question, and hopefully you remember these kind of questions for the exam because they do come up quite often. All right, that's question 1.